My name is Emil, and I'm pleased to introduce Gill Cleeren, who delivered today part 2 from his webinar Metro and WinRT for Silverlight and WPF Developer. If you missed part 1, you can watch the recording on Silverlight Show website. It was quite a successful and highly attended session, so I recommend you to watch the session. I want to make a note that this session might take slightly longer than our usual webinars, perhaps about 75 minutes for the session and a short 10-minute Q&A. Before I give the word to Gill, I'd like to remind you that you're welcome to submit any questions that you have using the chat option in your webinar panel. Gill will address as many questions as possible at the end of his session. Okay, so now I give the word to Gill. Gill, shall we begin?
Of course. Thank you, Emil. Hello, everyone. Good evening or good morning, depending on where you're listening from. And so welcome to this second part, as Emil told you, in which we are going to dive deeper in Metro and WinRT for the Silverlight WPF or Windows Phone developer, let's say for the current XAML developer. So come on, there we go. For the people who don't know me, so my name is Gill Cleeren. I work as a .NET architect at Ordina in Belgium. I'm a Microsoft RD and a Silverlight MVP. And I'm doing a lot of sessions all over Europe, and I was at DevReach as well in Bulgaria, where Silverlight Show is also based. I have my own user group in Belgium, which is called Vizug. I've written a book. More on that in just a second, because you can win it. I put up my blog as well as my email address on there, as well as my Twitter, so you can follow me by simply adding at Gill Cleeren. That's the simplest way to reach me. I'm almost 24 hours on available on Twitter. So as Emil already mentioned, you can ask any questions you may have through the Q&A window. I'm happy to answer as many as possible at the end of this talk. And the webinar is also being recorded, so a link to the video will be sent to you afterwards, so you can watch it again at your own pace, and you can also download the slides as well as all the demos of this talk from the Silverlight Show website as of tomorrow. You can win. So if you complete the webinar webinar survey, afterwards, you can win one of the ebooks that will get you ready to get a Microsoft certification on Silverlight, which is the exam 7506, and you can also win my book in ebook format, the Silverlight 4 cookbook, that is, by tweeting about this webinar. Anything, suggestions, feedback, questions you may have afterwards, simply tweet them by using the tag webinar Silverlight Show, and we will pick them up, and some people will be selected afterwards. Everybody who is attending this webinar will get some discount on Telerik controls and on packed ebooks on Silverlight. The code will be sent to you for both these promotions afterwards as well in an email that we'll send out tomorrow. And just to make some small publicity, so my new book is also on the horizon. It's actually almost here. It's going to be on Silverlight 5. It's entirely updated, and it's also extended. There's it's a cookbook as was the Silverlight 4 one. So we have added about 30 new recipes specifically for Silverlight 5, as well as covering other topics including Windows Phone, MVVM, and a much deeper dive in RIA services. You can already pre-order it. It's going to be released in about 4 weeks, so one of the first weeks of March, and there's a link at the bottom where you can get some more information about it as well. So with that out of the way, let's get to the Windows 8 content. So in this part, we are going to be talking about the following points. So I'm going to start by talking about styling and templating in Windows 8, and of course using XAML technology. And we're going to see how that changed or has not changed when moving forward from Silverlight or Windows Phone to Windows 8. Then we are going to dive into the data area, which is a very important aspect of almost every application, be that a business app or simply a newsreader app or a stock ticker or stuff like that. A lot of applications need data. We're going to see how that works in Windows 8. Is it still asynchronous like in Silverlight? Do we need to do something else? How about what about data binding? Is that still in there? We're going to see that as well. Then we are going to see some more information about the application lifecycle of a Windows 8 Metro style application, which, as you'll see, is very similar to the way that the Windows Phone application lifecycle works. And the same goes for tiles. We'll look at tiles as well in Windows 8 applications. Again, that is very similar to what we have in Windows Phone. It is more extended, but the base principles are the same. We'll finish this talk by looking at some more information about input and output, so I/O in Metro apps. There's several ways of doing I/O. So to the local disk, can we do that? Where can we do that? But also applications need to store settings, and we'll see how we can do that in Windows 8 applications as well. These are the topics that I covered in part 1, which was recorded about a week ago. So we took a look at the general XAML stuff in that webinar. We also focused on the new controls, which was actually a big chunk of that talk. We looked at the grid view controls and the list view controls and many more. So I encourage you to take a look at that webinar if you haven't seen it. And we finished that one by looking at navigation. So head over to silverlightshow.net to watch the recording on demand. So just to set the stage a bit more for the people for whom this is the first part they're attending, we are focusing, of course, on the Metro apps that we can build with Windows 8. And we're focusing on transferring your current knowledge, your current XAML knowledge that you may have gathered from building applications in Silverlight, in Windows Phone, or in WPF. And we're going to see how that translates to Windows 8 Metro style application development. In the previous part, we did a small gimmick, which was actually giving you a small batch. It's not, it's only a virtual batch, of course. It's basically whenever you know or whenever you already know something currently in XAML, we try to transfer that to the to Windows 8, and if we succeed in that, you get a new batch. There's 5 new batches to actually win in this webinar. So you should already have 3 from the first part. Okay. So with that out of the way, we're going to start by taking a look at styling and templating. And there is a badge that you can win, which is the Stylish Windows 8 Developer. You may ask yourself, do I want to be a stylish developer? I leave that in the middle, but anyway, that is the badge that you can win if you already know about styling and templating from your current XAML knowledge. So, what about styling and templating? If you've taken a look at Windows 8, at the Metro applications, you probably have noticed that applications have some distinct look and feel, have a distinct style. That style is actually the Metro style, and it's typical, for example, to have a dark background, a black background, some very basic styling that is applied on most controls, and that Metro style is, of course, very similar to the Windows Phone Metro style. There you also had a button that is basically not more than a rectangle around some text. It's a very clean and very modern and minimalistic style, that Metro style, and Windows 8 actually builds on that style that was probably first introduced with Windows Phone 7. Now, in Windows 8 applications, when we build any new application, as we'll do in just a second, in the project template, there is already a lot of information for these styles. So the styles that controls are going to be using are built in or baked in into the project templates. So the default styles are included. That means that if you know how to build custom controls, you simply need to build a new control template in a file which is called generic.xaml. And that generic.xaml implementation is out of the box available with when you build a new Windows 8 application. So that means that all controls that you are going to be using are getting a new style, the new Metro style applied from that generic XAML that comes along with Windows 8. So the default styles are included in there. And as we'll see in just a second, you see that concepts that you know in terms of styling, like resource dictionaries and the basic concept of a style, is exactly the same as we've known it all the way from a Windows Phone and Silverlight development. Windows 8 has by default a dark and a light resource dictionary. This is again more or less the same as in Windows Phone, where we have a light and a dark theme for our applications. That is more or less the same concept in Windows 8. In the SDK that you can download today from the Windows 8 developer, from the dev.windows.com website, there's a lot of samples in there, and most of these samples have two XAML files, which are called generic XAML and light generic XAML. They have more XAML files, but these two are actually resource dictionaries. And as you can probably deduct from the naming of these two files, you see that generic.xaml is basically the dark is the default style. And you can open that style and start changing it where you want if you need that for some particular reason. The light generic actually contains, well, a light theme. Again, both these files are built by declaring a lot of default styles, and therefore they are picked up automatically by Metro style applications. Let us take a look at these two themes in action. So let us go to styling and templating. That is this particular demo here. And we are of course using Visual Studio. I'm using the Visual Studio 11 here. You can also do the same thing with the Visual Studio Express for Windows 8 Metro applications. So I'm going to run this application first. There we go. So you see here at the very bottom that these controls are now in a light theme. You can see that the button is light gray, the toggle switch is also light gray. And when I click on this dark theme here, automatically I'm switching actually the resource dictionary for that particular, I think it's a grid that sits around it, to a dark theme, to another resource dictionary. I'm actually applying a different resource dictionary. These are the default styles that come along with Windows 8, basically. These are the default styles that you can get out of that generic XAML and that light generic.xaml. That is built up out of a lot of default styles that are automatically applied on all controls unless they define or they refer to another style. And you see that they are actually dependent on the actual theme that is being used here, as you can see. So let us take a look at this in code. So as you can see, we have a generic XAML and a light generic.xaml. These are two quite big files, as you can see. It's thousands and thousands of XAML lines. And when I, for example, that's a good place to stop. In this light generic, I have a style, which is a default style, and it's set to, the target type is set to textbox. It has the style declaration for the default, for the text block in the light style. If I go to generic XAML, I will find the same thing here. For example, here we have the toggle button. In the main page, I'm basically switching between these two by simply hiding one of the stack panels. So in here we have the stack panel. I think that is the dark one, yes. So I'm using the resources property bag in which I apply the resource dictionary and I refer to generic.xaml. In the other one, I would have referred to light generic. So these are default styles. You can change them, but they are automatically compliant, let's say, with Windows 8. Okay, let's go back to visuals to the slides. There we go. Now, all the things that we know from styling are still valid. You've already seen most of it. So things like putting your style information in line, it is still possible. It is still possible to actually place on a stack panel a background in line. That is still possible. So properties in line is still possible. That is still not a good idea. You probably should use a style for that, so that you can bundle everything in just one location, update the style in one location, and have it applied all the way throughout your application. Then concept of a template, a control template, which is actually changing the way that the control looks, is also still possible. It is a viable solution, but it's certainly not a perfect solution. A better solution to build custom controls is probably visual states in combination with the parts and states model. The parts and states model is easier to work with than control templates in most cases. We're going to take a look at each one in a bit more detail. So as mentioned, styling remains the same as it was previously. So you still have the style keyword. You can give it that style a name, which is done through the key property, and then you also give it a target type. That is, of course, required. The target type basically refers to which type the control can actually be applied. The concept of an explicit style is basically a style like I just explained. It has both a key as well as a target type. The implicit style is a style without the key defined. So it just has a target type. So the ones that you saw in the light generic and in the generic.xaml, those are implicit styles. They will be picked up by any control unless it has another style applied on it. And then we have the based on property still available for a style, which allows us to define styles basically in an inheritance tree. So we can create, for example, a base style with just the font applied to it, and several styles based on that particular style, which have a different font size. That is still possible. So templating, is actually referring to saying, well, I want to redesign how a button looks, for example. And how do you do that, or how did you do that in Silverlight? Well, you could go to the MSDN website, copy the control template, paste it in your code, and start changing it. That gives you the ability to completely override how the control is actually being visualized. That is okay, and it allows you to, for example, build a button like this thing here, which is like a circle with more or less like a play button. It's okay to do, but it's certainly not a perfect solution. A better solution is the Visual State Manager, and I mentioned there again in the title because we saw the Visual State Manager already in part 1, where we used it, for example, to go to switch between different states of our Metro style application. For the people who are not familiar with the Visual State Manager, it's a concept available in Silverlight and in Windows Phone as well. It allows you to define how a control should look in a particular state. And what do I mean by a state? Well, a state is basically like if you have a button, it can be in the regular state, so it's just waiting to be clicked. It can be in the pressed state, it can be in the mouse over state, and so on and so forth. So basically what you have then is that in using the Visual State Manager, you can simply define how the control looks in each of these particular states. It's just redefining the visual template for each state. Let us take a look at this in a bit more detail in a demo. So let's go to this one. And so there we go. Oh, I didn't have to do that. There we go. So let's run this thing to start with. And I'm going to show you a style, a template, and a visual. Oops, yeah, it's the one. So this is the style. So here we have a regular button, and I'm going to paste in another button, and I'm going to style that. As you can see, with styling you can do the regular stuff like changing the fill in this case, or the background, and the fonts family, and so on and so forth. So this is done. Let's jump to, come on, there we go. So I'm going to scroll all the way down, down. Still a bit further. Styling should be somewhere over here. There we go. So this is that button that you saw appearing, and it has a style which is called custom button style. If we search for that, and let me go to the next instance. So this here you see that we have a style which has a key and a target type. So it's an explicit style with a setter and with several setters which have both a property and a value property. That is how the style would have worked in Silverlight and in Windows Phone as well, and in WPF as well. We can also template the control. So this is like the way that you can do it, but in most cases will not be doing it. So what I'm going to do here is, so this is a new button, and as you can see, there is no, I'm clicking this button now, there is no mouse over, there is no pressed information. This is still a button, but you wouldn't say it's actually still a button. Now how come? Let's go down a bit more. So this is this refresh button style that's applied on this particular button. And, oops, no, didn't have to do that, sorry. So let's search for this one now. There we go. Not this one, this one. So this is again a style, and in this style there's a template property, and in there I have a control template defined, which has a grid, and it has an ellipse and a text block, which is what you saw here. So it's an ellipse, and there's an image in there, and it's a text block below it. So that is that style. As you can see, there is no way that that Windows 8 would know how this style would actually have to be visualized if you are pressing the button. It doesn't know that. So the template would have to be a lot bigger. To actually go around that, we can use another, and let me go back to the demo. We can use the Visual State Manager, which actually allows us to define how a control should look in different states. So you can see in the pressed state, this is the press state, this is the mouse over state. So I'm basically capable of defining how the control actually should look in these different states. So this is done by another style, which is the VSM refresh button style. And again, this should look familiar if you've done this in Silverlight. It has a template property, a control template, and then in the root container of that control template, we define a Visual State Manager, Visual State Groups. And here, for example, I'm saying that a mouse over should be an animation that changes the fill to this solid color version on this button ellipse, as you can see here. So this is exactly the same as I would have done it in previous XAML technologies. So with these demos finished, I think that if you've done this in XAML, you'll agree that this is nothing new that you have to learn. So you have earned another badge, which is the Stylish Windows 8 Developer badge. Okay, let's move on. Let's now take a look at working with data. And you can earn another badge, which is called the Data Master badge. Now, Windows 8 applications are said to be connected, are said to be alive with content. It's very hard to have a stock ticker without stock information. It's probably not going to be a very popular application. It's very hard to build a news reader without access to RSS feeds. In fact, I think it's clear that most applications, not all, for example, a game might only need a service, perhaps to get high scores. Most applications at some point will need interaction with some data source somewhere out there. Most applications will need data. Now, again, working with data in Windows 8 applications is very similar to working with data in Windows Phone as well as in Silverlight applications. The process is basically the same. You need to get your data into your application. Getting that data requires you to work asynchronously, and then you can use your data. For example, you have to parse your data. Then you can bind your data. All these things are possible. And if you're coming from a Silverlight or Windows Phone background, you'll probably agree that this is more or less the same process as it was in Silverlight or Windows Phone. Let's take a look first at the first step, getting data into our application. Now, getting data into your app, of course, requires you to access a service. At this point, there is no support in WinRT to work with a local database. There is no way to have link to SQL. There is no AD.NET in general available in WinRT. That might come, I don't know, in Windows Phone, with Windows Phone 7 Mango. We had the addition of a SQL CE database, so a compact edition database. Perhaps that is going to be added, I don't know. But I think you'll agree that working with live data is still not possible with just a local database. That local database in Metro-style applications should be perhaps interesting if you want to store settings, but we'll see later that there is other ways to do that. So working with data is most of the time going to be only possible when that data is behind some service. So that is the way that you work with relational data. By the way, it's also not possible, for example, to have in your Windows 8 application a connection string to some database. Of course, it's not possible. Everyone would be able to read the password of your database server. So relational data should be hidden, let's say, behind a behind a service layer. And we'll see in just a second a bit more on these services. Now, just to jump a bit ahead, local data is also going to be very important. So storing data on the device locally is also important. That is quite logical. There are several ways of allowing Metro applications to interact with the local file system, including storing files on specific locations, opening files on specific locations, or allowing the app to store data in its local directory. People coming from Silverlight or from Windows Home should immediately think about the isolated storage. Well, we have the same concept available in Windows 8 Metro apps. Perhaps a small side note on this. In Windows 8 applications, saving data, saving state data, I should perhaps say, is going to be very important. Users of your apps, of your Metro apps, are used to the fact that they don't have to save everything explicitly. They just close your app. In fact, they don't close it. They just put it they put it behind some other application. They bring another application in foreground. And at that point, they don't want to be bothered by you as a developer asking questions like, should we save your current state? Should we make it possible that you continue where you left off the next time? No, that should be implicit. Your app should do that automatically in Windows 8. People are used to that now. They have an iPad perhaps already, or they've worked on an iPad, or they're working on a Windows Phone. They are used to the fact that apps should store the state automatically for them, and they don't want to do it explicitly. In that case, working with local app storage is going to be very important. Now back to the services. Services, there's a lot of services already supported in Windows 8. XML over HTTP, which is a REST service. So REST can work over XML or JSON. ASMX web services. I haven't placed WCF in there. It's also possible. I should have placed ASMX or web services. And we'll see that in just a second. Sockets is possible as well. I haven't played with sockets, but it is possible. It's also possible, of course, to interact with an OData service. OData is basically XML. So there's basically no reason why you shouldn't be able to work with an available OData service. There is no RIA services support at this point. Again, I mean integrated support, like you have code generation. Maybe that will come at some point, I'm not sure, but I hope in any case that I will be able to use still use RIA services. Now, when you work with services in Silverlight, you're probably already used to the fact that services work asynchronously. Now, writing asynchronous code, what does it require? It requires that you make an asynchronous call and then define a callback, a callback method. So you basically say, do that call asynchronously, and then when the result is ready, execute this code defined in the callback method. That's how you do it in Windows 8. Sorry, in Silverlight and Windows Phone. Now in Windows 8, things are getting a bit easier by the addition of the await keyword. Await will make things easier. The await async await pattern basically allows you to specify that some line of code will happen asynchronously, and automatically all the lines that are below it will wait to get executed until that await line is actually executed and has called back. So basically you have like an inline callback method. That's where more or less what it looks like. And it's also basically what it does. It allows you to run your UI, to run your code on the UI thread. There's no way that no need to do like dispatcher begin invoke anymore. So that's not necessary. Okay. So let us take a look at working with data. That is working with data. And so I'm going to use an app that we used already in the previous webinar, not part 1, but the one that we started with last year on Windows 8. And there we used a Flickr application allowing us to search for pictures. I'm going to very quickly show it. Perhaps I should put a breakpoint in here. I'm not going to put a breakpoint here, but anyway. So we can search in this application for some pictures, and it's still quite cold here, so I'm inspired a bit by that by typing the word snow, and you can see you get some pictures being loaded containing snow. All right. Now this is of course XML over HTTP in this case, so that is the preferred way of working with Flickr. So how do we do that? Normally in Silverlight we would have used these lines of code here. You would have written a web client, and then you would have said client download string async, building up the URI, and you send the request to a URI and you get back the result, and then you have the download string completed, which is your callback. So this code in this download string completed method would have been called automatically and executed automatically. That has changed a bit, but conceptually it's still exactly the same. So here I'm calling the method create client, which is going to, instead of using the web client, going to use the HTTP client class. That's what you see here. I'm creating an instance of that HTTP client, and then I am going to scroll back up here. I'm now going to ask that HTTP client to make an asynchronous call. You see by the method name that this is indeed an asynchronous call, and I'm passing in where we should make the call. So this is the URL that we're going to search, that we're going to send the request to. And note the await keyword in front of it. This is now an asynchronous call being done. So whenever my code execution reaches this line, it notices the await, and it will actually pause. I shouldn't say pause. It actually makes the asynchronous calls. It doesn't block the UI thread, but these lines of code don't get executed before this call is complete. So this one completes, and at that point, this particular line is going to be executed. To have this work, you need to mark your method as being async. All right. Now, when this result is finished, we're actually going to parse it. I'm going to talk a bit about it in the next slide, but anyway, I'm going to run a bit already before. So as you can see here, we get in the response as XML. I'm going to read out that content into a string, and I place it into an XML document, sorry, an X document, which is something coming from link to XML, from Xlink in fact. And then I'm going to write a link query, as you can see here, so to parse my photo information. This is actually code I took directly from a Silverlight sample. And then basically I add to my grid view, I bind my grid view to a list of images. There's nothing different going on here. The most important thing to remember is that working asynchronously has gotten a lot easier using this await keyword. Okay, so this one, yeah. So we have the data, as we saw on the slide. We're getting in from Flickr a XML stream, and we have it, so now we can use it. So what can we do with the data? As you already saw, link is supported, so link to XML is supported. Note, link to SQL is not supported. That is quite logical. And of course, we can also still do data binding. All the things that we have come to love in data binding are available in Windows 8 as well. So a lot of new controls that you already saw last week, like the grid view, like the list view, support data binding, and also the new controls support this as well. Data binding, I'm not going to explain you what data binding is. You can read it here for yourself on the slide. Conceptually, exactly the same as in Windows, in Silverlight and Windows Phone. Technically, also the same. However, not every feature that you know in Silverlight 4 and 5 is supported at this point. What is supported, things like a value converter, the binding modes, all those things remain exactly the same as they were before. As mentioned, not everything is supported. There are a few things that are missing at this point. Let's hope that they will get added moving forward. The concept of a data template, we saw data templates already last week when looking at the grid view, is exactly the same. For the people who are not familiar with a data template, it's basically some XAML code that gets executed for each item in an items control, like a list box or a list view or a grid view. So instead of defining, so basically you are defining some template that contains some binding to an instance that is bound to that list control. Okay, let's take a look at data binding. I'm going to close the view of Visual Studios down here, and let's go to data binding. So let's take a look at data binding, and there we go. Let's run the sample. So the standard stuff like a one-way binding, a two-way binding, and a one-time binding is still there. For example, two-way binding, as you can see here, this text box is updating. If I am changing the value of this text box and I'm going to set it to 99, you can see that the slider is also updating. This is done using a standard binding statement. No, downward in the XAML. This one. So you have, for example, this two-way slider here, and then you have the text box. And so the text box is getting its text by binding. This is an element binding or an element-to-element binding. It's specifying the element name, as you can see here. I set the path to be value and the mode to be two-way. You should know this from any other XAML technology. The concept of a value converter is also available here. As you can see here, for example, when we move this value is actually converted into a letter grade. How did we do that? Well, we have a converter, which is here at the bottom, I think. Yeah, there we have it. So any converter is basically a class that implements the iValue converter interface, and it has a convert as well as a convert back method, which is not supported in this case, which is not needed in this case anyhow. And so we get in the value, in this case as an integer, and then we parse it, so we check if it's going to be lower than 50, and the grade is going to be F and all the way up to superstar, and that's the value that we return. In the XAML, using the value converter is done somewhere over here. There we have it. So the text box here is getting its name from that converter, from that slider, and it has a converter in here as well, which is called grade converter. That's an association of it through XAML. We can also do bindings to a model if we want to do MVVM. This is actually based on the concept of the data context. So the data context in this case, I think it is this block. Let me go to the XAML, so to C# code first. So as we can see, this scenario tree output, which is a stack panel, its data context is set to an instance of the employee class, and an employee has a name and an organization. And then, of course, I can do my regular binding stuff, like having a binding to name and organization. It will walk up the XAML tree just like it would have done that in other XAML technologies, so all the way up to the place where it finds a non-null data context, which is this scenario tree output. A data template is also still available, as you can see here. Here we have a data template which is actually making that that rounded rectangle around these items. So if we go to this one here, no, that's not this one. Here we have the list box item template, and we use a data template. And so we have in each one a border, and we're binding to a color, and we're binding to a name. So conceptually, for each of these of the items that's being bound, we're actually creating or instantiating this XAML for each item. So I think I'm not going to go show you all the demos. You can download them afterwards. I think that you'll see that and that you'll agree that, again, the data binding stuff has moved into Windows 8, making it possible for us to do all the things that we've come to love with data binding. So I think if you already know it in Silverlight or Windows Phone, you have earned another badge, which is the Data Master badge. Now let's briefly take a look at application lifecycle. And you can again win another badge, which is the Windows 8 Lifetime Achievement badge. That's a nice one, I think. Okay, so application lifecycle. If you know Windows Phone 7 development, things will probably again look very familiar. This is of course different from Silverlight, but again it's more or less the same as we have in Windows Phone. An application in Windows 8 can be running or it cannot be running. That's basically what you think that it can do. Because it can be in the foreground. If you've watched part 1, you may have noticed that we have the full screen and the filled state and the snapped state. Those are applications that are running. An application can run full screen or in the snapped or filled state. At that point, it is a running application. Now, why am I emphasizing that? Well, any application that gets started will be running at some point. It can be, as mentioned, in the full screen, it can be in snap state or in filled state. Now at some point, the user is going to say, well, I'm tired with your app now, I am going to do something else. And at that point, your application is not going to be the foreground application any longer. And it's going to enter the suspended state. Now, it is not happening immediately. There is a delay of 5 seconds before the application actually gets suspended. The reason for that is that if you're doing something, you're for example playing a game or I don't know what, and you want to quickly check your mailbox, you can click on the Windows key, go to start screen, see that you don't have any mails, and jump back to your game. At that point, your app will not have been suspended. It is still running. If, however, those 5 seconds are passed, your app will get an event about the fact that it's being suspended, and then it enters the suspended state. That is the only way for you as a developer to save state. That is the only way that you are notified about your app not remaining in the foreground, suspending your app. That's an event. We'll see that event in action. Now, at some point, the application might resume. That is an event that you get as well. So in the resuming, you may want to load in some state if needed to rehydrate your application. But at that point, your application is the same instance as it was before. So the application is not killed. It is still in memory when suspended, but it doesn't get any CPU cycles. When resuming, it's the same instance. Now, why then is saving state so important? At some point, the device will run out of memory. And it will say, well, yeah, sorry, application, I will need to kill you. You are not notified about your application being killed. You don't know. So that's why suspending is the only, the suspending event is the only place where you're notified about anything happening with your application. You don't get notified about your app being killed. You don't get an event for that. So suspending is the place where you should do it. And that is the only way of allowing the user to come back to your app, perhaps later today or perhaps tomorrow or in a week, to make sure that he still gets the same experience, that he knows, well, I was somewhere doing something in my app should remember. That is making a good experience. So as this I already explained, so you have the on-suspending event and the on-resuming event. The on-suspending is triggered when the application enters the suspended state. Now, in the SDK, there is something called the suspension manager. And so in the on-suspending event, which we'll see in just a second in the demo, you can get a deferral. Now, what is the use of that deferral? A deferral basically allows you to get some extra time to do your saving. Assume that, for example, you want to save something to a service that might not get finished before the application gets suspended. So you ask the application, well, please hold on so I can do my saving. And that is what you see here in suspension manager.save async, which, for example, is going to do an asynchronous sync to save to a service. And so before that line, you see that we have the suspending deferral, which we ask the suspending operation to get deferral. And that deferral, I say, well, now the application will wait to get to go into suspended state. Then you can do your saving, and then you set the deferral to complete. It basically allows you to get some more time. Then at some point, maybe your application will get resumed. You get an event for that. But as mentioned, and this is different from Windows Phone, this is still the same instance that is running, unless Windows Phone Mango, which is also a new state for that. But basically, this is not a tombstone state, if you know Windows Phone. This is not a tombstone state. This is basically the same instance that keeps running. Tombstone is the application gets removed from memory. Now, why are you interested in then your application being activated, resumed, not activated? Well, there are scenarios, for example, that you may want to rehydrate your data. If your application is a newsreader and it was suspended and only resumed a week after that, you would like to perhaps do an automatic call to rehydrate the application with new data. Now, how do you get notified about your application being launched or activated? I should actually say activated. There is, in fact, several ways possible to launch your application. We haven't seen contracts yet, and we actually won't be doing that in this webinar, but there are several ways to actually launch an application. You can launch an application directly from the start screen by clicking on the tile. But you can also launch an application from a search. You can launch an application by sharing data between applications using the share contract. So that means that there are several events that in your app XAML you can hook into to know how your application was launched, or activated. So for example, it can just be launched. It can come from a search. It can come from a sharing. It can come from a file picker, because the file picker allows you to search into an application. Or perhaps your application is launched because of the fact that someone has opened the file to which your application is a handler. So there are several ways to actually activate your application. And you can actually hook in the app XAML file to be notified about these. Let's take a look at app lifecycle. Let's open this thing up. There we go. Let's run it first. The thing is, at this point, there's not really that much to show, because apps can't be suspended, but I'm going to show you something in just a second. So at this point, the application is running. The application is launched. I launch it via Visual Studio. Let me go to XAML, and let me put a breakpoint in here. Let me be started because I forgot to put in this breakpoint. Let's restart it. There we go. So now the application has the onLaunched being triggered, and it has an instance of launch activated event arcs that are coming along, and they have a previous execution state. So based on this state, I know where my application is actually coming from. So now my application is actually coming from nothing, so it's actually launched. So I know my application is just getting a clean launch. Now if I want to suspend my application, what I can do is I can go to the debug menu, and then click on the trigger suspend, which is actually going to send the suspend operation to my app. Normally, this app would not have been suspended because it's on the foreground application. However, running it from Visual Studio from the debugger doesn't suspend your app currently. So I can trigger a suspend, and then in my application, I am registered for the suspending and the resuming event. And so in this event handler app suspending, I am actually getting this gets triggered when the application is entering suspended mode. So what I'm doing here is I'm asking to get that deferral as explained first. So to get some more delay to actually do my saving. Then here I'm using something called local settings. We're going to see local settings at the end of this talk. Local settings basically allows me to, store data in the application's own data storage. So application's data current local settings. It's an iProperty set. An iProperty set can be compared with a dictionary, key value. So here I'm going to check if a key scenario already exists. I'm going to remove it, and I'm going to add a scenario selected index, as you can see here. It's a dictionary. And then the application was suspended, as you can see here, and of course we can also resume it. It automatically gets resumed from your code, from Visual Studio. So this is the application lifecycle. This is the suspending event, which should be your place to actually store state, perhaps on the isolated storage, perhaps on a service, that's also possible. And the resume, it should be your place to perhaps check how long the application was suspended, and if it was suspended for a long time, well, then we perhaps should do some rehydrating of some live data. Let's take another quick look at the application XAML file. So as you can see here, I have the onActivated, which is actually triggered when launching the app from a tile. I have the file picker activation, and I have several other ones. So I had, for example, here the onSearch activated, which is basically when my app is going to be the target of a search operation, this one is going to be called. So these are the events that we can hook into to know how my application gets launched. And this one can be killed as well. All right. So if you know Windows Phone, these things should look familiar. And I think you can then add to your badge collection this new badge, which was the Windows 8 Lifetime Achievement Badge. All right. I have two more things to do. And the first one of the remaining ones is this tile building. Tiles and more, and it can earn you another badge, the tile building. So how can we earn that tile builder? Well, if you've seen Windows 8, the Metro interface, you probably have seen this particular screen. It is the new start screen. We explained it thoroughly in the first webinar. This is your Metro environment. Apps are represented here by tiles. These are all applications. It's basically a tile. A tile is an extension of an app. So these are all applications basically being shown. They're not running apps, they're tiles of your applications. Did you do some Windows Phone development? Well, then you already know what a tile is. It's an extension of an application that actually engages a user to take part or to open up your application. It draws the user into the application. It represents the application while the application is not the running application. It can receive updates. It can show updated content. It can do that. Same thing as in Windows Phone 7. Now there is some things that are different, of course. We are running on a tablet device and we're not running on a phone. So there is two types of tiles. We have regular tiles, which just show static content. And they can be shown in two sizes, a square or a white tile. Now, a regular tile is basically static. That's why it's regular tile. Most of the time, you'll probably want to engage your user more to use your app by using a live tile. And a live tile contains updated content, active content. It can be shown, it can be updated by by using a predefined XML template, which is actually defined in Windows 8. There are several templates available that you from your application can send to the tile, and the tile will automatically pick up that XML based on the template that you're using, update its contents. We'll see that in just a second. There are several templates available. Some are a combination of text and an image. Some are only text-based, some are only image-based. You can do updates locally, or you can do them from the cloud. So the concept of a push notification is the same in Windows 8. Here you see several tiles, tile templates being used next to each other. You have some which just contain a simple image. Some contain more than one image. Some contain text, a list of text, and so on and so forth. So as you can see, these are several tile templates being used from my applications. Secondary tiles also exist, and that's what you saw moving in. Then Windows 8 also contains the concept of a batch, which is an overlay of the existing tile. It's always shown on top of the tile as a number between 0 and 99, or one of the predefined glyphs in Windows 8. You can use those in your applications as well. They are shown on top of the tile. And also you have secondary tiles, again the same concept as Windows Phone 7. It is basically allowing the user to pin content to the start screen. So by default your application gets just one tile. Programmatically you can create hooks into your application, allowing the user to pin content to the start screen. Let's take a look at tiles. Let's open this demo here. This one. All right, we'll start by running the sample. So let's update the tile with some text. So I'm going to write some text here. Silverlight show. There we go. I want to push that content from my app to the tile of my app. All right. How am I going to do that? Well, I'm going to send some XML to my tile. That is the way that my application can communicate with my tile. It cannot just send any XML. The XML that we will send is some predefined XML, which is actually that XML template I was referring to. There's a lot of templates available. You can go through there's an entire list of templates available containing images, containing text. This one is just going to update my tile with some text. So when I click on this update tile here, you see the XML that my application has now sent to the tile. The tile recognizes that. It sees that it gets in XML that says tile-wide text 03. So this means that if my tile is white, we get this the tile will pick it up. If not, it will pick it up. It will ignore it. And then there is a text, IDs 1, hello Silverlight show. Now where does it end up? Let's go all the way over here. And here we see my tile being updated. You see hello Silverlight show. All right. Now let's update it. Let's update the batch, for example. I'm going to update it with a glyph. I'm going to say error, for example. Update the batch. Again, this is predefined XML. XML version, blah, blah, blah. And then we have here a batch. The value is error. Let's go back to the tile. And now you see here an error, exclamation mark. This is because I sent a new batch. Come on. And there we go. And now I'm going to update my tile with some images. I can do that with local images or web images. I'm going to do that with a local image. There we go. So again, this is using some predefined XML template. Tile wide image and text. So I'm going to send an image and a text. I'm going to send an image that is this particular PNG and also some text. If it was a square, I'm going to use this one. So here I'm actually anticipating to the tile being small or large. And this should actually show an image. The blue part is the image, and this is the text that we're using here. Okay. So let's take a look at some code for this. So let's take a look at this one. It's all very similar. I'm going to use this one. Let's see if this one is okay to explain it. Okay, so update the tile with some text. So what I'm going to do is I'm going to ask the tile update manager class to get a particular XML template. That's what you see here. I'm going to ask it, remember, that tile wide text 03. This is an enumeration. As you can see, there's a lot of particular templates at this point already available. So then I get in the XML. Then I need to do some XML manipulation. Here I'm going to search for the text element. I'm going to update its text with the text that the user has entered. This is updating the text box in the UI. And then more importantly, I'm going to create something called a tile notification, which is actually going to say to the tile, you need to be updated. I pass in the tile XML, and then again using the tile manager, the tile update manager, I use the create tile updater for application dot update, which is actually going to pass in the tile notification and is going to send that updated tile information to my tile. So as you can see, and again, we'll take a look at all the other samples at your own pace. They are very familiar, very similar how they work. So it's all basically the same that you have to do. So this really refers to some level, let's say, working with Windows Phone tiles. It's not exactly the same, but concepts like push notifications to update a tile, using a tile update manager class to actually update the tiles is conceptually the same. And of course, the concept of tiles comes from Windows Phone. So you have found another batch. So to round up this webinar, let's take a look at the storage API. And you can earn your final batch, which is called Mr. Input. Now, if you've attended last week's webinar, we have talked about the fact that Windows 8 applications run in the Metro environment, and they are more or less safe sitting there in their own little world, let's say. So they cannot just go access system resources like as they would want to. Conceptually, this refers, this reminds me of working with Silverlight. From a Silverlight application, I cannot just say, well, read out the Windows directory. Unless it is a Silverlight application that runs with elevated permissions, we cannot do that. We can access a file in Silverlight using the file open dialog. We can access, we can write to the disk in the isolated storage. unless you're running with elevated permissions, that is, because then you have more permissions, but regular Silverlight apps can't just do anything with local system resources. So this concept is more or less the same in Windows 8 applications. Well, it basically depends what a Windows 8 application can do with a particular file, depending on where that file resides. So for example, that file can be in the application data directory of the application. That is the concept of isolated storage. It can be a file locally on the device, on the machine, I should say. It can be a file that is sitting on my C drive. Can I access that? We can access, or we can want to access a file on the device, a USB memory stick, for example, or on a network. Or we can want to access an image or a file on the web. Based on the location of the file, my Windows 8 application will actually need to do different things to access that file, if it can be accessed at all. So based on the location, different restrictions and a different access model is in place for the file. So as mentioned, my Windows 8 app has full access on the local app data folder. So it can access any file that was created by the application in its own directory. We can delete files, we can create files, and so on and so forth. This is accessible via the application data.current.local folder. There I can create an image, read out that image, save settings. If I want to do that, I can do that manually by using some XML and storing objects and serializing and deserializing objects. I can do that all in that local data folder of my app. No one else can access that. No other application can access that. Now my application may want to access, for example, the library of pictures on my Windows 8 device. Now, to do that, a Windows 8 application has a manifest, and that manifest lists the capabilities of the application. If you have done Windows Phone 7 development, this is exactly the same thing. This the concept of defining what the application will do in the manifest file is going to be required when the application is going to be published in the Windows Store. Because then applications can define what they are going to be able to do with your application. If you don't specify that in the manifest file, you will not be able to get to the library. And when your customer will download your application, he will actually see in the Windows Store that your application is going to access or going to ask access, is going to get access to your library of pictures. So if you use content of the music, the picture, and the video library, nothing else is required. If you want to use files from the documents library, you actually need to specify file types that your application is going to work with as well. I'm going to show you that in just a second. One last thing. My application needs access to the C temp or the C whatever or the D whatever. Well, sorry, we can't do that. The only way to access files physically in the file system, you can do that only using the file pickers. There's a file open picker that allows you the user to select a file, and then your Windows 8 application will get access to that file. It can read out that file. That's again the same thing as with Silverlight with the open file dialog. Okay, let me show you how this actually works. So, well, I'll show it in the same sample. Let's take a look at storage, and we're going to first take a look at file access. Okay, so I was talking about that, declaring that my application needs access, for example, to the library of pictures. So, sorry, not here. In the manifest file, which is the package.apex manifest, Here I can, for example, declare things like the image, so the splash screen and so on, and the initial rotation. But in the capabilities, I can define the capabilities of my application. So these are the things that my application says it will need access to work to function properly. So if this application would read out images from the library of the picture library, then we need to check picture library access. If you want to do interaction, by the way, with webcam, for example, you need to check that as well. This actually is all reflected in this Apex manifest file, which we can open as an XML file. And so this declares the images that we are using, and also somewhere in here we can see the capabilities. As you can see here, we need to access the pictures library. Okay. So this application has the capability, and just to so this now has the capability to access the pictures library as well as the regular documents library. So it has now full access to that documents library. It asked the user to do that. Well, so now we can ask to create a file in the documents library. Create a file for me. The file was now created. Let's take a look at the documents library. Documents. You see that this file was created, as you can see here. We can even write stuff to it. Write to that file. Hello, Silverlight show. Show people. Write to that file. That content was now written to that file. Let's check it out. As you can see, the content is now in this text file. Now, how could we do that? Well, basically, the first thing is checking that my application will need access to the documents library. And then, let's create a file here. So create a file here. So I'm going to get the location of the known folders .documents library, which is actually getting the storage folder for the documents library. And then I'm going to ask it to create a file async, passing in the name of the file. Again, await, because interaction with the file system is technically slow. It can take more than 50 milliseconds, so this call is marked with the await keyword. So I'm creating a file, I'm updating the file, I'm writing to it. Again, take a look at this at your own pace. So this is how we interact with files. Remember, we need to ask or we need to declare that my application is going to do this interaction. This is going to be reflected when my application is published in the App Store. And the final sample I'm going to show you is what if you want to do stuff or save data locally. There are several ways of doing it. I'm going to show you one, and that is using that application data folder. If you're coming from Silverlight, you probably know the isolated storage settings. Well, this is basically the same thing. It's not isolated storage, but it's exactly the same thing that's happening here. So by using the Windows Storage Application Data Current local settings, I get access to an application data container. And that local settings has a values dictionary. It's actually not a dictionary. It's an I think it's an property set. Yes, and there I can start removing stuff, and I can start adding stuff. As you can see here. Here I'm adding something. I'm writing to that iProperty set a new element. If you want to see this running, we can do that very quickly. There we go. I'm going to write a setting. Now I've written to that. I've written now here, so I've added another instance to that dictionary, and I can of course delete it again. So this allows me to save data locally in the memory of my application. All right. So now that we've arrived here, I think conceptually the same thing applies here. You know that in Silverlight you cannot get access to the drive directly. You can access files via the open file dialog, or you can also write data locally in an isolated storage. It's not the same classes, but it's the same thing. So I think you've earned this badge as well. And so as you reflect on what we've seen in this webinar and the previous webinar, you see that most concepts that you know from XAML development carry forward into Windows 8. I'm not going to say that you are an expert now in Windows 8, certainly not, but you are certainly well on your way to becoming a Windows 8 Metro style application developer. And you can really take all the knowledge that you already have and make it or apply it in Windows 8 development. So I think you really earned another badge, which is the Windows 8 Metro App Developer. So I hope you enjoyed it. I hope you enjoyed the ride, taking your application, your XAML knowledge further into the Windows 8 era. And I think we can open it up now for some more questions. Emil, if you have some questions, I assume there is going to be a lot of questions again.
Yeah, thanks, Joe, for this session. We have some questions from our attendees that we will address in the next about 10 minutes. On a replied question, we'll get a reply via email, and then we will publish them on Silverlight show. So now I'm assigning you the questions.
Yeah. So in the meantime, I will already start with some questions.
Okay.
So someone asks, and apparently last time the questions were visible, so you can read along if they're still visible. I don't know. So someone asked if I already tried doing this with C++. Well, I'm actually not a hero in C++. I can write a few lines of C++, but no, I really don't know. However, what you've seen here is mostly the XAML part of things in combination with the WinRT API. So what you've seen here, what you've learned here, if you're coming from a C++ world, well, basically you will be able to apply the same things as well. So the WinRT API is projected into VB, into C#, into JavaScript, and into C++. So the classes are going to be the same. So you can really translate your app from the one into the other language very easily. Okay, I'm going to go all the way back to the top. That was this question, yeah. So someone asks if async is still the only way of doing interaction. I assume you refer to working with a service. Well, in that case, the answer is still yes. There is no other way to actually do interaction with the service. Asynchronous is going to be the only way, now more important than ever. Windows 8, as mentioned by Microsoft many times at Build, is all about performance. It's all about being a fast and fluid operating system that gives the user a great experience. So that's why they even extended async. So everything from accessing a service is of course still async, but many more things have now become async by default. So accessing a accessing a file on the pictures library, for example, like you've seen in the last thing, has to be done asynchronously. Every operation that can take longer than 50 milliseconds is by default made asynchronous. But by using the await async pattern with the new await keyword, it has become a lot easier to work with async. It's never been difficult to work with async, but if you've had to make several consecutive asynchronous calls, well, that code might not have been really clean, and you may have to work with events or stuff. Now with Windows 8, with the await keyword, which is actually courtesy of C#5, it has become a lot cleaner. Perhaps a small side note on that: if you are not working with C# but perhaps working with JavaScript, the asynchronous is there available as well, but in that case through a JavaScript promise. To conclude, well, everything is still async. Accessing the service is still async, and it has been extended a lot into the platform. Okay, let me see. Okay, this is an interesting question here. Can two applications communicate with each other if they belong to the same company? Well, let me elaborate a bit on this. I think this person here, this attendee, is asking this question because of the fact that by default Silverlight applications cannot have a direct communication, or perhaps also in Windows Phone. That is true as well. Now remember, we are now working again in a Windows world, so a lot more things are possible. Can applications communicate with each other? Yes, they can. By default, they can do that by using the sharing contract. So the sharing contract, as mentioned, I've touched on it very briefly, but I've not gone into detail, is something new in Windows 8. Applications can share data with each other through a contract. So they don't have to know each other. They basically use a pub-sub mechanism where Windows is like the mediator that sits in between. But they are basically going to send messages, and that is the sharing app is going to be able to send the message. Another app, perhaps from the same company, is going to register itself as a target app, and that way they can share data. So if you define a very specific message in this case, you can, for example, have several applications that communicate with one another. So that is perfectly possible to do. So that same person asks, the tile size is different. Well, yeah, indeed. You can define a small tile or a large tile or both. It's the end user that actually makes the decision on how your application is going to be shown. Okay. Let me see which are the most important ones. Someone asks, can we upgrade the existing project, I assume a Silverlight project, directly into Metro? Well, I think we talked about that in the questions last week as well. Well, no, in my opinion. I don't think you can actually do that directly. You can really not say, well, I have a Silverlight application, now open it as a Windows 8 application. I'm really not. I don't think it's possible. It's not going to be easy to do that by just saying, yeah, well, copy everything. What I want you to know is that your knowledge is safe. A lot of your code is safe as well. So Visual State Manager code, converters, data binding code, a lot of that is safe as well. But of course, there is going to be work in moving it from the one environment to the other environment. That is one thing. Also, things in Windows 8 evolve around a touch-based input. Silverlight, in most cases, are not applications that are built with touch in mind. So just saying I'm going to copy all my XAML and paste it in a Windows 8 application, well, that's probably not going to be the best experience, because when using touch, the user is actually when using Windows 8, users is probably, a lot of users are going to want to use your application based on touch. So simply doing a copy, well, may not be a good idea. Conceptually, yes, you can move it forward. Technically, you can move your knowledge forward as well. Direct mapping one-on-one, no, that is not possible. Again, it's a different world, it's a different environment. Okay, let's take the next question. Okay, so someone asks here, what happens to the data in the application current local settings when the application gets terminated? Well, or gets suspended, it doesn't matter. Well, that is actually key. This data remains saved between calls. That is exactly what's happening here. Conceptually the same as you have, for example, isolated storage. Isolated storage, even after your PC reboots, is not being removed. So that is still the same thing. In this case, we are now able to, well, save data in that local settings dictionary, it's the IPAP set, and get it afterwards again. Someone asked here if it is possible to run Windows services to actually create a background process or background service in Metro. As far as I know, that is not possible, and as far as I think, that is not going to be possible anyhow. That is, I think that is having a background service, a Windows service, is not something that is possible in Metro anyhow. So that is not going to be possible. Someone asked here, is secondary tiles are possible in Windows 8? Well, yeah, they are possible to create. I haven't touched on that. There are some samples in the Windows 8 SDK that show you how to create secondary tiles, I think. But yeah, I haven't touched on that. We can't do everything here. Okay, that was this question. So the tiles that you perhaps let's quickly jump back to the tile thing here. A lot of these tiles that you see here, hopefully on the screen now, are secondary tiles. So you can create those as well from within your application. I think there was a slide in here that mentioned secondary tiles. Sorry. So here, for example, these are secondary tiles pinned to the start screen, allowing you to, for example, pin a particular weather location to the start screen, and allowing the user to pin as many as he wants to the start screen, giving the user, well, the option to personalize his start screen using your application. But it's something that you need to develop as a developer, which part of your app is going to be possible to expose as a secondary tile. I think I already created. Someone asked if behaviors are available. I don't think they're available. I haven't tried that, but I don't think they are available at this point. I'm not really sure. I should check that, but I'm not really sure. That was this question. Can I detect network drives and enumerate on that from a Windows 8 app? Well, I'm pretty sure you can't. Again, it's something that I haven't tested, but I don't think you are able to do that because it would. No, I don't think you can do that. That's not going to be allowed, I think. And someone asked here if it is possible to, or if there is any size limit to application storage. Well, I think not, but I should look it up. But I don't think there is any size limit. And the last question, that's one that I have to look up. So I'm going to come back to that by mail. So Emil, I think we're through the questions.
Okay, great. There are just a couple of questions left, but we'll answer them by email. So thank you, Drew. I think it was a very good session, and thank you everyone for attending. I invite you to fill out the survey displayed just after you exit the webinar. 3 of you will win Drew's ebook on getting prepared for the Microsoft Silverlight exam. A recording of this webinar as well as all demos and slides will be made available to you and emailed within the next 2 days. So that's it for now. Thanks again for attending and have a good day or night. Bye bye.
Bye bye. Bye bye.